Hi everyone, I am Kavya Shivareddy. Student ID is st20313229. About my research, today I will present on the topic of predictive modeling of student success using learning analytics. The present contribution is aimed at discussing the potential of using machine learning to transfer educational data, accurate and visible predictors of academic performance based on the Open University Learning Analytics Dataset or OULAD. I created and tested several models to predict which students will end in one of the four categories, which are pass, fail, withdrawn, and distinction. The performance goal the performance goal was target at a high accuracy rate, the optimal interpretability, and the usability via a gradient-based interface. To start with, we shall have a look at structure, the structure of the presentation. So next, we want to discuss about the outline and the agenda of this research project. So first we're going to discuss about the introduction and background, and then aim, objectives and research questions, literature review briefly, and then methodology, key findings, discussion and implementations, limitations, recommendations, and also conclusion and future work. So next we have the background and context. So in these, colleges are under pressure to enhance their retention rates, and this means that universities are under pressure to identify at the risk students early. The development of online and blended learning environment has contributed to massive volumes and learning data, particularly in virtual learning environmental or VLES. Machine learning provides an effective means of processing such data and arriving a meaningful action. The majority of the current research has been done on the binary perspectives of pass or fail, but touch does not touch on the more complex themes. It also lacks interpretability and the deployment in the real world. The proposed reaction in the position helps to fill this gap by the proposing to create a deployable multitask, multi-class, and explainable machine learning framework. Next, we have the research aim, objectives, and the questions. So, in these studies, sought to develop an explainable and a multitask machine learning models to predict student academic performance using OULAD, and also deliver the model through a user intervention radio interface. The objectives were to conduct a literature review, combine both educational, and behavioral characteristics, train and test several algorithms, explain the result through SHAP, and create a feasible interface. It has been conducted and informed by a set of 5 research questions that has been verified between the possibility of such predictors as well as which features are algorithms and the most effective as interpretation can be achieved in the case of such predictions, and how the systems can be simplified to become accessible to other parties. And then we're going to discuss about significance and the literature review. Multitasking prediction offers more information than binary based models, assisting teachers in providing personalization to the investigations. Research demonstrates that behavioral characteristics such as VLE clicks and submission product patterns has a strong influence on success. The most important thing is explainability. Methods and shape can be for foster foster trust in a forecast. Fewer studies implements models in a practice in education. The study contributes to previous research on multi-class classification, interpretability, and deployment. It fills the research to instructional use gap, providing a repeatable models that combines the latest in machine learning with open source tools available to educators. So now we're going to discuss about the methodology. It was a quantitative and detective research which has positivity philosophy. The OU-LAD dataset was adopted, containing seven files with a large files, simple sampled to 100 sampled to 10% efficiency, pre-processing of the data, encompassed filling in missing values, removing outliners, converting categorical variables to numeric and scaling numeric features, logistic regression discussion tree, KNN, ZX booster were trained. The performance of the models were measured through accuracy, precision, recall, F1 score, and the confusion matrix. It also utilized the SHAP in its methodology to achieve interpretability along with the Gradio. The deploy visit ensured it was not only technical reboost but is also usable to the non-technical users. So next we're going to discuss about the challenging and the ethical consideration. So in this, several issues were delayed within the research, satisfied simplifying and the smooth were involved to reduce class imbalance. The simple managed the large dataset without assisting the statistical diversity. Trust in the black box model has been addressed through the introduction of SHAP to explain some of the moral aspects involved being GDPR complaint and also the privacy of students in all data management process. The method show that with strong pre-processing ethical protections and interpretability features, it is possible to address practical and methodological limitations to the use of machine learning in sensitive educational data. So now we're going to discuss about key finding one, dataset insights. So if it is pass is equals to the majority outcomes, then distinction. Fail and withdrawal are less frequent. The behavior engagement is strongly linked to the academics. So now in figure 6, we'll see overall distribution of final results, and in figure 7 we'll see the final result distribution of gender. So in this, the blue color will describe about the pass and the orange is distinction, green will be a withdrawn, and red is going to be a fail. And in second key findings, model performance, we have KNN, highest accuracy 97% and balanced class performance, and ZX boost strong with the imbalanced classes, integrates with the well with SHAP, and then logistic, and then logistic thing. In figure 8, we'll see about the comparative visualization of model performance matrix, and in table 1 we're going to see about the comparability performance of a classification models, and then in key factoring 3 shape analysis we're going to discuss about the shape analysis. So in this, the top features are assessment scores, VLE clicks, and studied credits. Then the prior attempts and registration timings affect outcomes. The engagement and the academic behavior are key to success prediction. These are the features which will be describing about the shape of the prediction. Next, the discussion and implementation. Discussion and the implication. In this, the study finding fully respond to the 5 research questions, indicating that the multi-class predictions are available, interpretability, and practically applicable. They enhance the necessity of behavior engagement information in predicting results. The example of the Gradio interface shows how complex machine learning models can be simplified for non-tech audience, and the combined technical research with a practical use of such models. Such findings promotes forward-looking instructional approaches to enhance retention and academic performance, and also it helps indicates the necessity of explainable AI in education. And these are the limitations, which is single institution dataset UK based, only 10% of large field used, no deep learning methods tested, now static datasets lack real-time adoptions. And recommendations, it collect richer behavioral data for the earlier warning systems, integrate ML tools into academic supports workflows, train staff on interpreting predictive outputs, explore deep learning and real-time LMS integrations, maintain ethical and transparent datasets. In the conclusions, we have ML can predict multi-class academic outcomes with high accuracy. KNN outperformed others. SHAP adds trust and transparency. Radio Gradio interface bridged the technical practical gap. Frameworks adaptable for other institutions. So in future works, the possible future studies could be used deep learning models which are possible to detect more complex patterns than classical missions. Learning predictions could be used in real time and enabled by the integration of learning management systems, so that educators could take action during a systems towards such as anti-prediction, scalability, and generability could be tested by enlarging the study to more than one institution. Long-term effectiveness could be improved by the development of adaptive models that could learn new changes in students' behavior. Lastly, the possibility of implementation hybrid on enhancing methods may be beneficial to the complexity or on the strengths of more than one algorithm, which may lead to the better rates of the accuracy and interpretability with regard to the prediction of the student outcomes. In it, I ensured the reference material that was directly used in designing the research and the conducting the analysis. The entire list of the reference can be found in the dissertation. These work discussion the application of machine learning to educational prediction, the necessity of behavior features, the issue of multi-class classification methods, and the usage of AI methods that are interpretable, such as SHAP. Both were instrumental in defining the ideas and the implementing this project. I wanted to acknowledge the guidance of my supervisor, the support of my department, and the Open University, which provide access to the OULAD dataset. I would also like to thank my family and friends who encouraged me in this project. And this is my presentation, and I do welcome any queries if you may have relating the methodology which we methodology, the findings or the potential use of this study. Thank you.